Good day viewers, today we'll be deriving electric power formula. And to do this, the first thing we need to know, we're using so many terms to do this. So the first thing is potential difference, V. Potential difference is the work done in moving a charge around a circuit Q. So this is potential difference equals to work done over charge. So our work done, when we cross multiply, making work done subject to formula is equals to the potential difference times charge Q. So the second variable we'll be using here is what we call power. Power is defined as the rate of work done over time, that is work done per unit time. So we are to substitute for work done, which is Q times V here. Then I'm having power is equals to Q multiplied by V all over T. Now, the third term we'll be using is electric current. We all know electric current I is equals to the quantity of charge Q per unit time. So this we cross multiply, making Q subject of formula. Q will be equals to I all over T. So let's replace Q here with I over T. That is, modifying this equation, I'm having power is equals to IT times V all over T. Now this T, we cancel this T. I'm left with power. This is our electric power is equals to I times V, or in order of magnitude V times I. Now the last variable we'll be using here is what we call the Ohm's law. Remember, Ohm's law states the current is inversely proportional to the potential difference and directly proportional to the resistance. V is equals to IR. So we are going to replace this IR here with our V here. So power is equals to I multiplied by R multiplied by I. So the power in the electric power formula is equals to I square, I multiplied by R multiplied by R, where I is our current in ampere and R is our resistance in ohms. Thanks for watching today's video. Don't forget to like and subscribe.